Hi, good day to everyone. And now we are going to see a video clip about the IAMC project, which is the Improved Agriculture Moisture Control Project. And in this video, we are going to deal in detail about the decoding techniques of the sensor values which are being obtained in this project from a moisture control sensor variable. Right now, going into the video, we have processed this decoding technique using the LabVIEW software provided by the National Instruments, and here is the layout of this. You can see it right clearly. And going into the explanation or the description of this layout, cumulative sensor output is what is a string value which the receiver sensor or which the receiver gives into this, which is a string value which has a number of 16 characters, among which the first character indicates the plot from which the sensor values are being obtained, and the following 15s are divided into 3, from which each 3 are a value of one sensor output from the corresponding plot. And thus we have 5 sensors, and we have sensor 1 output, sensor 2 output, 3, 4 and 5 respectively. And what we are going to do is we are going to find the cumulative or the average moisture value from a single plot by getting the values from the sensor and finding the average of it. We are going to use a case structure loop, which is here, which is the main part, which is gonna select which plot is being active and which values we are going to get in, and that is what we are going to see right now in this case structure. Precedingly, we have to split the values of the string into 3. The first one indicates the plot from which the values are obtained, which is 1, 2. At times it may be 0, during which the receiver remains idle. And so for that we are going to keep a string subset from which we can easily split the values, and these are the string subsets available. Each subset we are using it for dividing, and this value is what is known as the offset value, and offset value is used in order to eliminate the initial value of the strings. For example, the offset value 0, it is being entered here, which means we are eliminating none of the string values, and the above one is length of the string which you have to give it in. So 1 is the length we have mentioned here, and so 0 is the offset. We are not going to delete any character from the string, and the string length 16 is not going to go inside, rather than we have mentioned 1 as the length, and thus the first character alone goes into it. And respectively you can see the following, which we have divided into 3, and thus it goes like that. And coming into the case selector, what we have done is the plot what we have mentioned is we have using here as the case selector. You can see it clearly right here. This is what is the case selector. In case if the first value is 1, plot number 1 is getting activated here, and in case it is 2, then the control automatically shifts the plot 2 value. For instance, if we have no values, or if we have some other values rather than 1 or 2, which is not a desired value, then what should be the output? You can see it here. We'll have an invalid plot selection as the indicator, which means there is no plot such that's available here. And there is another one case which we have to look in, which is very important, the 0 case. In case if we don't any of the plot value which is desired, it is 1, 2. If it is 0, then what action is to be taken? Is we should not get a 0 moisture output, since it is not desirable to us. We will just show off the previous value, where the very recent previous value of the moisture value we have obtained. We will show it here, and this we have achieved by activating a local variable. The scope of the local variable lies outside the case structure, and thus we can have it, and you can see it clearly here. The moisture value here is the local variable we have used, which gives the very recent previous value of the moisture value. And yeah, and there is one more constraint in this when we are giving to it. A string output cannot be given into a formula structure, and thus it has to be converted into a number so that the formula can be easily activated. The formula what we have used is a simple average formula, x1 plus x2 plus x3 plus x4 plus x5 the whole divided by 5, where x1, x2, x3 etc. represents the sensor values, the sensor output values 1, 2, 3, 4, 5 respectively. And that is the formula. The main drawback of the formula is we cannot insert a string into it for calculation. Thus, a number value is only allowed for a formula calculation in LabVIEW. So thus we are creating one more subset, which is an decimal string subset, which gives a number as the output from the string. The string which we give certainly contains 3 variables as I told earlier, and these 3 are converted into number, and this is again converted into number. Each values are respectively converted and they are given into the formula loop, and this is where the action takes place. This is how the front panel looks of our LabVIEW VI, and this cumulative sensor output is what the string which we receive through the SPI, which is got from the ESP receiver. The ESP receiver receives the sensor values, and which is given as a string through an SPI, and this is what is the string, where this one is what the first variable is what we mention for the plot values. If it is 1, it indicates plot number 1. If it is 2, it indicates plot number 2. And the following 15 variables, the 004, 005, 6, 7, 8, etc. are the values of the sensor output which we get from the SPI connections. And this is what it looks. The sensor 1 output is here, sensor 2 is here, 3, 4, 5, etc. are given here. The active plot number is what we indicate which plot is being active, which means the sensor values that are obtained from the which plot is, we can see it from here. And this is another plot number. If it is 1, we get the answer 1 in this area. If it is plot number 2, we get it in this area. And this invalid plot selection is what we saw. If it is an undesired condition, if it is plot number 3, 4, etc., we get it as the invalid plot selection through a string indicator. The moisture value 1 is nothing but the average moisture value which we obtained from the plot 1, and the moisture value 2 is the average value that we obtained from the plot 2. This moisture value is what I have said before as the local variable that we have set in order to indicate the very recent moisture value if in case we get the string first initial value of a string as 0. This is what is the local variable, and here we can see the very recent value which we obtained, the very recent moisture value, we can see it here. And that is it. From this front panel we have all these instructions that a viewer can view from this.